All right, so I've had a request for exercise 13A, number 9. So I'm going to go ahead and work through A and B. My hope is to be able to kind of talk through the process of what's going on and kind of what's going on in my mind as I work through this question. All right, so let's go for it. Let's go ahead and start with part A. You can read all the information, you've got it there. The things to recognize, I guess, from the question itself is that it gives us the probability distribution function of B, which is this one right here, and then it gives us the cumulative distribution function right here. And you've worked with the probability distribution functions already. Cumulative distribution function is the same thing, it's just adding everything up that's that value or lower, and you can see that here. So this is the probability that your random variable is less than or equal to some number. So the probability distribution function would be that the variable is equal to, say, 3, and then the cumulative distribution function, remember when we did the cumulative distribution tables, we added up everything that was below that value. And so that's what it is here. It would be 0, 1, 2, and 3. I guess 1, 2, and 3 because it's positive integers. All right, so that's the idea of what's going on with these distribution functions. Okay, so now what we're going to do is we're going to go straight into part A, which says show that for this discrete probability distribution, if y is greater than or equal to 0, then these two probabilities are equal to each other. All right, now I'm going to work with both sides. Okay, we should try to work only with the left-hand side, but sometimes working with the right-hand side is necessary for us to be able to make some connections. All right, so we've got the probability that b is greater than or equal to x plus y, given that b is greater than or equal to x. All right, now if I use my conditional law of probability, then the top here would be the probability that b is greater than or equal to x plus y, and that b is greater than or equal to x, just like that, all over the probability that b is greater than or equal to x, just like that. Okay, now we're going to go ahead and try to simplify this a little bit. Okay, now we notice a couple of things right off the bat. One, hopefully you can see that up here, if b is greater than or equal to x plus y and b is greater than or equal to x, well, if y is greater than or equal to 0, then this group will always include this group, right? This group of the b is greater than or equal to x, if it has to be and, it's the intersection, right? So think about a list of numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So just consider those numbers for a second. If we say that x is, for example, 5, then b being greater than or equal to x plus y, right? b being greater than x plus y would be anything that is greater than that x. So we said x here was 5, right? Which meant that it was anything above. Now, depending on what y is, right? If y is, say, 0, then that means that x plus y would be 5, and we want to cover all of that. The intersection would be the green and the yellow there, right? But what if y was a different number? What if y was, say, 2, right? Then this would be 5 plus 2, which would be 7, and so it would be 7 and greater. What would be the intersection? Well, the intersection is still the green and yellow. So hopefully what you see, and you can put any number in for y, and hopefully what you'll see is that the intersection of these two groups, b is greater than or equal to x, and b is greater than or equal to x plus y, that the intersection is always going to be exactly the same thing as your x plus y. This was the x plus y, and this was just greater than or equal to x, right? Your intersection is always going to be identical to this x plus y. And so that's what we're going to do in this first step. I guess next step is that we're going to rewrite the top as just being the probability of b is greater than or equal to x plus y, because that is exactly the same as that intersection, which we could see over here as we kind of talk through and reason through that. Okay, awesome. So now we need to figure out how to rewrite these guys as something that we can work with, right? The problem right now is that both of these are greater than or equal to, right? And I really want less than or equal to, which I can see up here in the problem, right? They gave me some information. And so because it's less than or equal to, I want to be able to, I need it in less than or equal to, otherwise I won't be able to work with what I have, right? I won't be able to use the formulas up here. So now I need to find out the connection between something that's greater than or equal to and something that's less than or equal to. So I want to rewrite each of these. So let's go ahead and look at this bottom one first, just because it's a little simpler. It only has x. All right, so let's go back to our question and consider, all right, if this was b is greater than or equal to 5, right? So we're going back to our number line here and looking at 5. How could I rewrite this? Instead of b being the probability of b being greater than or equal to 5, how could I rewrite this so that it's a probability of something being less than or equal to a number, right? Well, hopefully you've recognized that greater than or equal to 5 includes all these numbers. So therefore, I should be able to use the complement, which is b is less than or equal to 4, right? That would give me this amount. And because that's the complement, if I go 1 minus that, that should be equal to the original probability of b is greater than or equal to 5, because this is everything else. So 100% minus that should give me the right-hand side. All right, so we're going to now rewrite this, okay, that b is greater than or equal to x is going to be equal to 1 minus the probability that b is less than or equal to. Now notice that this number is 1 less than that one, so we're just going to go x minus 1, just like that. Okay, and we're going to be able to do the same thing up on the top. Right? We're just going to treat this as a group, right? And so we're going to say 1 minus the probability that b is less than or equal to x plus y, and then minus the 1. We're using the same reasoning that we did over here on the right-hand side. If you want, you can go through that same set of reasoning for the x plus y, right? We said x plus y, for example, is 7. So now we need 6 and below. That would be x minus y minus 1. And below that, and then subtract it from 1. Now we have it such that we have the less than or equal to. Because we have the less than or equal to, we can now use the formula that's been given to us, right? So we're going to go ahead and put that in. So the top is going to be 1 minus. Now instead of the probability of b being less than or equal to x plus y minus 1, we're going to put in this formula, which would be 1 minus p. Now p is whatever probability we have there, so that's not going to hurt or bother us. That b that's the power is the b that the big B is less than or equal to, which in this case is x plus y minus 1. Just like that. And then the bottom, we'll do the same. 1 minus, and then instead of this, we're going to write 1 minus p to the x minus 1. Just like that. All right. And from this point, it's just a bunch of algebra, right? So we're going to take the minus and distribute it. We'll distribute it to the 1. We'll distribute it to the minus here. Same thing with this minus. Distribute it to the 1 and distribute it to that negative there. The 1 minus the 1, of course, will cancel out. The negative to that, here, we'll write it out. So this will end up being 1 minus 1 plus 1 minus p to the x plus y minus 1. And then on the bottom, we've got 1 minus 1 plus 1 plus p to the x minus 1. And of course, these cancel out. That would be 0. Then we're left with 1 minus p to the x plus y minus 1. And then on the bottom, we've got 1. Sorry, that is not a plus. I said that, but it should be a minus there. Sorry, this is a minus. 1 minus p to the x minus 1. And remember, when you're dividing things that have the same base, then what we can do is we can actually subtract the exponents. So x plus y minus 1 minus x minus 1 is going to leave us with 1 minus p to the y power. Okay, so this is pretty far simplified. What I'm going to do at this point is I'm actually going to go look at the right-hand side there now, because I want to see what that right-hand side looks like. All right? And that side is the probability that b is greater than or equal to y plus 1. Okay, now we're going to use the same reasoning that we did up here, in that we can rewrite that. That is the same thing as 1 minus the probability that b is less than or equal to y. Right? We subtracted 1 from here. We changed it to the less than or equal to inequality, and we subtracted from 1 because now I have the left-hand side and I want to get the right-hand complement. Okay, at this point, if we put in our cumulative distribution function, you'll recognize that what we get is 1 minus, and then for the probability b is less than or equal to y, that's 1 minus p to the b power, which in this case is y. And so again, you can distribute the minus, and what we end up with is 1 minus p to the y, which is equal. Whew. Glad that worked out. All right, so that is part A in showing that work. All right, part B asks us to interpret such and such. Now, on an IB exam, it's very likely that they would use the word hence, which is a clue that you should use the previous information. Hopefully you recognize that you see the greater than or equal to, you see the given, see another greater than or equal to, you see a probability on the other side, right? So hopefully you're recognizing the connections between A and B, all right? So if I look at those formulas in A and B, right, I can see if I'm matching up the left-hand sides here, right, that x would be 10, right? And if x is 10, 10 plus y needs to be 15, so y needs to be 5. And then over here, if y is 5, 5 plus 1 is 6, right? And so these two things are connecting. Now, what exactly does that mean? Well, that just means that these two probabilities are the same, right? The probability that you're going to win with 6 or more is the same as given that you've bought 10. Okay, this one, obviously, if you are going to get 6, then it should be given that you've bought 1. Okay, but the idea is that given that you've bought 10, okay, the probability that b is greater than or equal to 15, remember these two things, we said that if I put these two together, right, this becomes the probability of b is greater than or 15 over b is greater than or equal to 10. The idea is that if these two probabilities are the same, right, then buying these 6, your first packet, your second packet, your third packet, your fourth packet, your fifth packet, and your sixth packet, the probability in winning in one of those first 6 is the same as the probability in winning in your 10th packet, 11th packet, 12th packet, 13th, 14th, or 15th, right? You see that there's still 6 packets there. So the probability in winning in these 6 packets is exactly the same as the probability in winning in these 6 packets. Now, the answer key uses a word, they use the word memory. Now, basically all that means is that buying more packets, each event is not going to affect the other events. The fact that I've bought 9 packets here already, right, in the first set here, the fact that I already bought 9 packets and I'm now starting on my 10th packet, the first 9 packets don't matter. It doesn't matter if I won or lost in those first 9 packets. starting now, the probability of me winning is exactly the same if I buy the same number of packets. I bought 6 packets here, I buy 6 packets here, and so therefore the probability is the same, right? As I start to increase, because this is greater than or equal to, right? So as I start to buy more packets, as long as I buy an equal number of packets, it's the same on both sides. And that's what they want us to recognize, is that in a situation like this, if the probability is always the same, and if there is no memory, if earlier events don't affect later events, then these probabilities will be the same. So hopefully that makes sense. Let me know if you have any questions, and we'll talk to you later.